Hi, and today we are going to learn the cost estimation in chemical engineering. So, in the case of the cost estimation, if you take an example in the refineries or in the case of food manufacturing industries, cost estimation plays a very important role. So, in this case, if you take a general expression, the net profit in any chemical plant is given by the total income minus all expenses. So the net profit in a chemical plant is given by the total income minus all expenses, and it is important that a chemical engineer be aware of the many different types of cost involved in the manufacturing processes. So in this case, this all expenses is again divided into two parts. This all expenses is again divided into two parts. That is the direct expenses, and another one is indirect expenses. So in the case of the direct expenses, we need to manage the raw material expense for the plant, and we need to manage the labor, we need to manage equipments in the plant, and in the case of the indirect expenses, these expenses include the administrative salaries, and the product distribution cost. And in this case, we know that our total capital investment is equal to the fixed capital investment plus the working capital investment. And in this case, the fixed capital investment is used for the physical equipment facilities. So this is mainly used for the physical equipment facilities, and this working capital investment can be used to keep the raw materials and products in hand. To keep the raw materials and products in hand. The very classic example of the keeping the raw materials in hand is in the case of the dairy industries, where the cheese once produced is kept for the cheese curing, or which is also called as the cheese maturation. And in this case, the cheese is kept or stored in the dairy for about 6 to 7 months to improve the texture, to improve the taste of the cheese. And in order to store this cheese, we need to build a storage block. So when we build a storage block in the dairy industry, the material which is produced needs some expenses. Okay, so without wasting our time, we are going to solve some of the classic examples which are dependent upon the cost estimation. So here is the first example, and before directly putting hand to the example, I'd like to introduce the term which is called the cost index. So in the case of the cost index, it is merely an index value for a given in time, showing the cost of that time relative to the certain base time. Means the cost index is different for different years. So in order to get the deep understanding of this cost index, let's solve an example which is dependent upon the cost index. And here we have our question. The purchased cost of the 50-gallon glass line jacketed reactor was $8,350 in 1981, and estimate the purchased cost of the similar 300-gallon jacketed reactor in 1986, and by making the use of the capacity exponent as 0.54, and the index value in the case of the year 1981 is 721, and the index value for 1986 is 798. So here we are gonna use the basic expression. So the cost of equipment at present is equal to the cost of equipment at past into capacity at present over capacity at past to the power the capacity exponent times the index value at present divided by the index value at past. So from this given data we know that the cost of reactor whose capacity is 50 gallon is $8,350 in year 1981, and we need to find the cost of the same reactor in the year 1986 whose capacity is 300 gallon. So by making the use of this expression we can write the cost of reactor in the year 1986 whose capacity was 300 gallons is equal to the cost of equipment at the past, means the cost of equipment in 1981 is $8,350 into the capacity at present is 300 gallons over the capacity at past is 50 gallon to the power the exponent is 0.54 times the index value at present, means the index value in 1986 is gonna be 798 over 721. So let me take out my calculator. So here we have 8350 into 300 by 50 to the power 0.54 multiplied by 798 divided by 721. So the cost of the reactor in the year 1986 whose capacity is 300 gallon is equal to $24,319.56. So let's take another example. And in this case we have the purchase cost of the cell and tube heat exchanger with 100 feet square of the heating surface was $3,000 in the year 1980. What will be the purchase cost of the similar heat exchanger with 200 feet square of the heating surface in 1980 if the purchased cost capacity exponent is 0.60 for the surface area ranging from 100 to 400 feet square, and if the purchased cost capacity exponent for this type of the heat exchanger is 0.81 for the surface areas ranging from 400 to 2000 feet square, then what will be the purchase cost of the heat exchanger with 1000 feet square of heating surface in 1985? And the given data is index value at 1985 is 813 and the cost index at the 1980 is 675. So here what we know that the cost of heat exchanger in the year 1980 whose surface area was 100 feet square is equal to $3,000, and what will be the purchase cost of the similar heat exchanger? Okay, so the cost of heat exchanger in the year 1980 whose surface area is 200 feet square, we need to find this. and the exponent is 0.60 for the area ranging between 100 to 400, and here we are dealing with 100 from 200, from 100 to 200, and so we can use this exponent. So we know that the cost of heat exchanger in 1980, that is the cost of heat exchanger in 1980. Okay, so what we are gonna do is, here we have $3,000 times the capacity at present is 200 feet square, that is the surface area, divided by 100 feet square to the power, our exponent is 0.60. The range of this exponent is from 100 feet square to 400 feet square, and here we are dealing with from 100 feet square to 200 feet square, so we can wisely make use of this exponent. And do we need an index value for the same year? Okay, if you need an index value for the same year, they are gonna cancel out, so 675 over 675 is unity, so we are gonna take it as 1. So let me take out my calculator. So this is 3000 multiplied by 200 feet square divided by 100 feet square to the power 0.60 is 4547.14 dollars. So the cost of the heat exchanger in the year 1980, whose surface area is 200 feet square, is 4547.14 dollars. And further, what we need to do is, in the purchase cost of the capacity exponent for this type of heat exchanger is 0.81 for the surface area, which is ranging between 400 feet square to 2000 feet square. Then what will be the purchase cost of the heat exchanger with 1000 feet square of heating surface? So we need to find the cost of heat exchanger in the year 1985, whose area is 1000 feet square, is equal to question mark. So here in this case, if we make use of this value, but this value is calculated for 200 feet square heating surface area, and the exponent is 0.81 for the surface area, which is ranging between 400 to 2000. So what we need to do is, we need to calculate the cost of heat exchanger in 1980, whose surface area is 400 feet square. So the cost of heat exchanger in 1980, whose surface area is 400 feet square, can be given as the cost of heat exchanger in 1980, whose surface area is 100 feet square, times 400 over 100, and as we are dealing with the surface area between 100 to 400, we can make use of this exponent. So this is to the power 0.6, and as we are dealing with the same year, so this will, index value will get cancelled, and the cost of heat exchanger in 1985, so the cost of heat exchanger in 1980, whose surface area is 400 feet square, is equal to $6892.190. So we are gonna make this value, we are gonna put this value in this equation to calculate the cost of heat exchanger in 1985. So this will be equal to $6892.190 times 1000 feet square over 400 feet square to the power exponent, as we are dealing with the heating surface area between 400 to 1000, so we can make the use of this exponent. So 0.81 into index value at present is index value at 1985, this is 813, over the index value at 1980 is 675. So this will be our 6892.190 times 1000 by 400 to the power 0.81 times 813 over 675. So this is gonna be equal to $437.14. So the cost of the heat exchanger in the year 1985, whose heating surface area is 1000 feet square, is equal to $17437.14. But in some cases, instead of dealing with the areas, we will deal with the weight of the reactor, and we have the problem which is dependent on the weight of the reactor. So here we have our question. The purchase and installation cost of some pieces of equipment are given as the function of weight rather than a capacity. An example of this is install cost of the large tanks. In 1980, the cost of installed aluminum tank weighing 10 to the 100 times 10 to the power 3 pound was $390 into 10 to the power $3. So here we have the cost of, let's call this a tank. Okay, cost of tank in the year 1980, whose weight was 100 into 10 to the power 3 pounds, was equal to $390,000. For the size range from 200 into 10 to the power 3 to 10 to the power 6 pound, the installed cost weight exponent for the aluminum tank is 0.93. So the exponent is 0.93 for the weight, which is ranging between 200 into 10 to the power 3 to 10 to the power 6 pound. And if an aluminum tank weighing 700 into 10 to the power 3 pound is required, then what is the capital investment needed in the year 1998? So we need to find the cost of tank in the year 1998, whose weight is 700 into 10 to the power 3 pound. So this is equal to the cost of equipment at the past, means the cost of the tank in 1980. So this is 390,000 times the weight of the tank at present. This is 700 into 10 to the power 3 pound divided by the weight of the tank in past. So this is 100 into 10 to the power 3 pounds raised to the power, and the exponent is 0.93 into the index value at the present, that is the index value at 1998 is 1200 over 675, which is equal to 390 into 10 to the power 3 multiplied by 700 over 100 to the power 0.93 multiplied by 1200 divided by 675. So here the cost of the tank in 1998, whose weight was 700 into 10 to the power 3 pound, is 4235,291.02 So let's take another example where the capacity exponent is not mentioned. So when the capacity exponent is not mentioned, we are directly going to make the use of the 6/10 factor rule. So here's an example which is dependent upon the use of 6/10 factor rule. If a centrifuge cost for rupees 5,000 in 1990, find the centrifuge cost if the capacity is double. In 1990 the cost index is 200, and in 1996 the cost index is 250. So we know that the cost of equipment, that is centrifuger, in the year 1996 is equal to the cost of the centrifuge in year 1990. So 5,000 multiplied by the capacity of the centrifuge in 1996 is double. Okay, so this will be 2 times. Suppose the capacity in the year 1990 is C1, so divided by C1 to the power exponent. Okay, they have not mentioned the exponent, so here we are directly gonna use the 6 by 10 factor rule, so this will be 0.6 times the index value at present, that is the index value at 1996 is 250 over the index value at the 1990 is 200. So here, so 5000 multiplied by 2 to the power 0.6 multiplied by 250 over 200, so this will be equal to 9,473.22 rupees. So the cost of this centrifuge in the year 1996, whose capacity was doubled, is 9,473.22 rupees. So this was the all information regarding the cost estimation in any chemical industries, and perhaps we dealt with the basic problems. We'll meet in the next video with some more advanced problems, and till then, bye bye, and thank you for watching this video.